So for these problems, we are going to have to figure out if we are going to use geometry or antiderivatives to solve these definite integrals. So first we have the integral from 4 to 0, which I notice is kind of strange because normally our lower bound is a lower number. So we want to think about properties of integrals we might have to use here. And then we have the square root of 16 minus x squared dx. I already can see I can't use the power rule on this. This is not, by the way, the square root of 16 minus the square root of x squared. I know that a lot of you are thinking like, oh, maybe I can, or some of you, not a lot maybe, but some of you are thinking maybe, oh, I could just separate that into 4 minus x. But that is not the way it works. If you are under a square root and you have a plus or a minus, you cannot separate them. And we do have a minus there. So I do have to just leave it the way it is. So I cannot rewrite this as x to a something power. I've got x squared, but that's within a square root. We've got a 16 here. So there's no way for me to rewrite this and use the power rule or the backwards power rule. So let me think if I know how to graph this. And I do, because in page 1 of your notes in this class, you graphed something very similar. And you should know that this is a semicircle. So if you plug in 0, you get 4. If you plug in 4, you get 0. If you plug in negative 4, you get 0. So we have a semicircle here. I'm just going to draw a quick sketch. And we are going, it says from 4 to 0. Okay, so if you want to think about that, that's backwards, right? So if you have 4 to 0, you can either think of it as like going backwards, or you can just think of it as like, okay, well, I can just pull out the negative because I know that there's a property of log that says I can switch the bounds and then just make it negative. Okay, so you can switch the bounds and make it negative, or you can think of it as moving backwards. Either way, you should have a negative component. And then the area under the square root from 16 minus x squared from 0 to 4 is a quarter of a circle. So that's going to be negative 1/4 times pi r squared, which is negative 4 pi. And remember, when you are solving definite integrals, you do not have to put units squared. For this next problem, all right, so I have a square root, and I kind of just noticed that first, although I have 1 over x squared. I'm going to have the same problem here. But basically, when I graph it, I'm not given like a nice shape. Okay, it looks like a semicircle. It's not. So I don't have an equation that I just have like memorized in order to find the area under a square root. Same with 1 over x squared. 1 over x squared looks like this. It's kind of this rational function. I do not have a formula to know the area under that shape. So that tells me I'm probably going to have to use the power rule. So I'm going to first rewrite this so that I have x to power, so x to the negative 2 plus x to the 1/2. Notice that as I'm rewriting it, I am writing the entire integral. I am not just rewriting the function separately. I still have an integral there. I am still solving the integral. The only thing I've changed is that I've rewritten f of x. Then when I take the antiderivative, then I am going to take it out of the integral part. So the antiderivative of x to the negative 2, so it'll be x to the negative 1, because you have to add 1 to the power, and then it'd be negative in front. So the antiderivative of the antiderivative of x to the negative 2 is negative x to the negative 1, and then just double check. If I take the derivative, I get x to the negative 2. Likewise, if I add 1 to the power here, that's going to be x to the 3/2. To undo the 3/2 in front, I have to multiply by 2/3. And then I'm going from 1 to 4. So make sure that your notation is correct here. And then I can plug in, you can rewrite this if you want first. So this is negative 1 over x plus 2/3. X to the 3/2 is the same thing as the square root of x cubed, or the square root of x cubed, if you'd prefer that, from 1 to 4. All right, and then if I plug in 4, I get negative 1/4 plus 2/3 times the square root of 4 is 2 cubed, minus, and then plug in 1, so that would be negative 1 plus 2/3. And make sure that you are subtracting with your second group with parentheses to make sure that you distribute that negative. So I get negative 1/4 plus 2 times 2 to the 3rd is 16 thirds, minus negative 1 plus 2/3 is negative 1/3. So plus 1/3. And I'm going to go ahead and just simplify a little bit. So here's a common question. How much do I need to simplify? I do want you to simplify if you already have common denominators. But if you do not have common denominators, like here I have a denominator of 4 and here I have a denominator of 3, I am okay with you leaving this answer. So, and they are okay with that on the AP test as well. So if this is a free response problem on the AP test, then you can just leave it with different denominators and not combine them. If it was multiple choice, it would have a denominator of 12. And they would actually get a common denominator and add. But in this case, you do not have to do so because it is a free response problem. So I'm okay. Again, if it's easy, like 16/3 plus 1/3, that's 17/3. But if it's something like a third minus a fourth, I am okay with you leaving them separate. Okay, for this problem, I noticed that I have an absolute value symbol. And do I know antiderivatives of absolute value? No, I do not. So I am definitely going to have to use graphing for this one. So I'm going to do my best to do a fairly decent sketch. So I'm going over 2, up 4 for my vertex. My slope is negative 2 on each side. So down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. And I'm going from negative 1 to 3. So that's going to be this area above the x-axis. And then I'm going to have this area below the x-axis. So let me start with my area below the x-axis. That is a triangle. So the area of that is going to be negative, because I'm below the x-axis, 1/2. My base is 1, and my height is 2. And just make sure that your answer is a negative number here. So if you accidentally put negative 2, because that is the y-coordinate, that's fine, but then you'd have to make this positive 1/2. So either way, just make sure that your answer is negative. So negative 1/2 times 2 is negative 1. And then we're going to add some positive areas. So I've got this area here, which is a positive triangle. So that's going to be 1/2. Your base is 2 and your height is 4. So that's going to be 4. And then I have this other positive area here, and that is a trapezoid. So that's going to be plus a width of 1 times the average of your heights. So the first height is 4, the second height is 2. And then that becomes 6 over 2, which is 3. All right, and then I add those together, and I get 6. So again, just keep in mind the area below the x-axis is negative. And just make sure your sketch is nice enough that you can clearly see like what the heights are and what the widths are and everything, and what shape it is.